So what I have here is an example of a recommendation argument. In fact, it's a little dialogue, and within the dialogue, there is a recommendation argument. So what I'm going to ask you to do is schematize the argument here. In fact, I'm going to ask you to do two things. One, schematize the argument here, and then number two, look at your diagnostic tributary and label the support as trace data and non-trace data. So go ahead and pause the video and read through it, and then when you unpause it, I'm going to show you the answer. Hey, and no cheating. Okay, go ahead and pause it. Okay, welcome back. So here we go. Here's what it looks like. The overall main conclusion is that Jim shouldn't stay up late. This is a recommendation argument, so that's going to be the form of your overall conclusion. Here is our main argument. So if Jim stays up late again tonight, he'll be scatterbrained for his presentation tomorrow. Being scatterbrained for his presentation is bad, and the joy that he gets from staying up late and playing the game doesn't outweigh the benefit of doing well on the presentation. So the overall conclusion is that Jim shouldn't stay up late tonight. Okay, now the intermediary step here, this is really just a prediction argument, really. If he's scatterbrained, sorry, he was scatterbrained today because he was up late. And oh, what connects the past to the future here? What's the connecting condition? Well, he's not going to have time for a nap before his presentation tomorrow. So that leads us to the conclusion that if he stays up again late tonight, he'll be scatterbrained for his presentation tomorrow. And then that brings us to the very end here, our diagnostic tributary, that Jim is scatterbrained today. He was up late last night playing video games, and he's scatterbrained today because he was up late. Now, one thing that I want to point out, and I want to focus on this diagnostic tributary here. This is a diagnostic argument just like in Chapter 5. So what makes it a diagnostic argument? Well, first thing, how you can tell is you've got the double line here, and CD1, that just means diagnostic tributary. But what makes it diagnostic is that this conclusion is explaining some of this support. It's explaining either S1 or S2 or perhaps both. Now notice in these here, in these arguments, especially in the main argument, our conclusions don't explain any support. These are not diagnostic arguments. Only this one is a diagnostic argument. Okay, so what I want you to do now is I want you to look at S1 and S2 and figure out which one is trace data and which one is not, right? Or maybe they're both trace data. But give you a second. Now remember what trace data means. Trace data means that it's getting explained by a conclusion. So in fact, what you could do to help you out if you need it is look at this argument and ask, what's my implicit question and what are some rivals? Right? So the implicit question is something like, why is Jim scatterbrained today? And you can think of some rivals and then look at the support and say, do any of these rivals explain this support? Okay, so look at S1 and S2, figure out if it's trace data or non-trace data. All right, so S1, in fact, is our central trace data. CD1 must explain S1. It easily explains S1. But if you look at S2, clearly this one is non-trace data. That he was up late last night playing video games. The fact that he's scatterbrained today doesn't explain why he was up late last night playing video games. So S2 is non-trace data. So this is something that I will do in the exam. So I will ask you to schematize a recommendation argument. You'll do so in these 3 steps. And then I'll say label the trace data and non-trace data. And that's only something that you're going to do here in the diagnostic tributary. And you're just going to figure out, well, does this support get explained by the conclusion or not? Okay, well, I hope that helped. Good luck, and I'll see you online.